Jai Hind everyone, myself Puneet Saini, Assistant Professor, Mechanical Engineering Department, Ajay Kumar Garg Engineering College. I welcome you all to the third lecture of the subject Mechatronics, which code is KME052. It is a subject taught in Mechanical Engineering 5th semester as a departmental elective. So till now we have completed 2 complex topics from each of the units. So in our subject there are total 5 units. We will briefly discuss what we have in previous 2 lecture, what we have discussed till now, and what is the agenda for today, and in our next 2 lectures what we will be studying. So total there will be 5 lectures constituting important topics from the subject of mechatronics, topics which are important from exam point of view, marks which can be asked in examination, we will be focusing that. So in this subject we have studied unit 1. Important topics from unit 1 was studied about the evolution, what is mechatronic system, what was the definition of mechatronic system, and we studied about the control system concepts. Control system meaning how do we control a machine and what kind of operations does we want the machines to perform. So we studied that in this topic. Control system is eventually a big subject which is taught for electronics and electrical students, but here as we know mechatronics is an amalgam of mechanical engineering and electrical engineering, electronics engineering. So to understand the basic grasp of control, how do we control a machine, here it is introduced as a very small topic. In unit 2 we discussed about sensors and transducer. Now let us imagine a system of a machine. For example, let us take an example of an electrical motor. It can be any motor, DC motor, servo motor, stepper motor. So a motor performs a certain task, and at the end of the motor, at the shaft of the motor, we can attach gears to perform different functions. Like for example, if I take of new age of electric vehicles, there is a motor attached to it which perform the functions of moving the car from one place to another. So a motor is essentially an output device which is a actuator. It performs the output operations. Now if I take another example of a robotic system, what a robot do is, if I take example of an industrial robot, it consists of sensor which gather information from surroundings. Now the sensors are called as input devices. Now these information that the sensor gathers, they give this information to the controller. Now controller is essentially a brain which decides whether a certain task is to be performed or not. Now the performance of the task is done by an electric motor. So information is gathered from sensor, sensor transform that information to controller. Controller is essentially a brain, and then it gives signal to the output devices which can be a motor, and it then takes a decision. The controller takes the decision and motor will perform the task. So this subject is essentially divided into these sections. First is the introduction, and in unit 2 we discussed about the input devices which is sensors and transducer, and now in unit 3 we will be discussing about the output devices which is actuation system. So in our unit we will be studying about 2 different types of actuation, which is fluid based actuation and electrical actuation system. In fluid based actuation we will be discussing about actuating a machine with the help of a fluid power or pneumatic power. Pneumatic actuation means, pneumatic essentially means air. With the help of air, which is in compressed form, we do certain specific task. And next we will be studying about electrical actuation. Electrical actuation means the power required will be electrical, and example of electrical actuation is a motor. Apart from these 2, there are also many types of actuation. One of the type is mechanical actuation. Example of mechanical actuations are gears, belts, pulleys, and yes, these are all examples of mechanical actuation system. And in unit 4, we will be discussing about controller. As I told earlier about, controller is the brain. So a mechatronic system essentially constitutes of an input devices, a brain and output devices. So here in unit 4, we will be discussing about the controller, and in industry, a controller named as programmable logical controller, PLC, is used. So we will be discussing about that and programming techniques, like how do you program a controller. To program a controller, we opt a specific type of programming which is known as ladder language or ladder programming. We will be studying that in unit 4. And unit 5 deals with the application of mechatronics, like in control of conveyor motor, sorting and packaging unit, pick and place robot, how a mechatronic system work in that way, operation of bottling plant, domestic machines, car parking system, engine management system. These are all the applications of mechatronics. I give you a brief example of mechatronic application. Like traditionally, like 20 to 30 years back, if you see the automobile of that generation of 1980s and 1990s, they were quite heavy and there were very less electrical parts which was used to govern the engine. But if I talk about the engines or the cars that are coming today, there is a connected car technology. From here I am sitting with my smartphone, I can switch on the car, I can switch off the car, I can roll down the windows, I can turn on the air conditioner. So this is essentially an example of a mechatronic system. It means we are controlling the mechanical equipments which are there in the automobile with the help of a smartphone, which is essentially, you can say, an electronics equipment. So this is an example of, and how you are controlling it, you are controlling with the help of sensors and signals. So these are the example of mechatronics application. So in unit 5, we will be discussing that. So our today's agenda, I will be discussing about electrical actuation, because these are important from exam point of view. And I will be discussing about the switching devices, which is a solenoid. How does it work? And we will be covering a special type of motor, which is again very important from exam point of view, which is a DC motor. So let us jump to our presentation and start it. So let us start by studying the definition of an actuator. So an actuator is a device which converts electrical energy into physical energy. Electrical energy meaning we are getting energy from electricity, and converting into physical energy meaning we are, with the help of this electrical energy, we are making some physical work, we are doing some physical work. Or we can say an actuator is a component of a machine that drives the mechanism or a system. For example, if I talk about an electrical actuator, the shaft of a DC motor or a stepper motor is used to do various stuff. Like I take an example of an industrial robotic arm. To move an arm, suppose this is an industrial robotic arm. If I want to move this hand of mine of an industrial robotic arm, there has to be a motor attached to it. The rotation of the motor controls the movement of this whole arm, like from this point to this point. So at a joint, there is a motor attached, and on the shaft of the motor, we attach it in such a way that it helps in the motion of the arm. So this is what an electrical actuator is all about. It helps us to drive. It is a component of a machine which helps to drive the mechanism or system. Now, there are various types of actuators. Few types are listed here. One is electrical actuator. Its examples are relays and solenoid. Another is solid state switches, which are diode, transistors, MOSFETs, thyristor. Drive systems are DC, AC and stepper motors. All of these examples are of electrical actuator. And there are also mechanical actuators. In examples are gears, belts and chain drives and bearings. So these two are examples of one of the types of actuators. There are other types also, pneumatic based actuators, hydraulic based actuators, right? So let us proceed to our next slide. So to activate an actuator, we do need is a switch. Now you can think of switch as like in your household, you turn on a button to switch on the light of a room, or you turn off to switch off the light of a room. So actually, how does it work? One of the types of switch is a relay. So let us try to understand what is the actual mechanism behind a relay work. So relay were used as switches in old time, in early automation days, like in decades and 60s and 70s. today now also relays are used, but at that time relays were used in extensive number. So relay was essentially a switch. It was helped to connect various lines in an industry. So what is a relay? A relay is an electrical operated switch. It is nothing but a switch, also called an electromagnetic or electromechanical switch. The heart of relay is an electromagnet. So the main part which governs an relay is an electromagnet. And what is an electromagnet? A coil of wire that becomes a temporary magnet when electricity flows through it. So we know this phenomena that if we generate an environment like this, in which there is a coil and we pass on the electricity, it becomes magnetized, right? So this is how this is the fundamental of behind the relay. Now there are four components in relay. One is electromagnet, one is movable armature, contacts and spring. Now let us see the example, the diagram of relay. So this is a coil and this is a DC supply. It is being fed to the ground, and here in close vicinity there is a metal bar, and through this metal bar there is a spring attached, right? Now let us see how the relay works. Now when a small current flows in the input circuit, now suppose this is the input circuit, here is a DC supply attached of 5 volt. Now as current flows through this, it activates the electromagnet. This is an electromagnet. It activates it and produces a magnetic field all around it. So as we switch on the current, an electric field is produced all around it here. This energized electromagnet, now this becomes an electromagnet, and this energized electromagnet pulls the metal bar in the output circuit towards it. Now here is the metal bar here. As this is energized, it will move in this direction and it gets attached by this. Here our circuit gets completed, and here there is an output from where you can drive anything, or it's acts as a switch, right? Then output circuit. Closing the switch and allowing a much bigger current to flow through the output circuit. So here much bigger current can flow through the output circuit. Now what happens if we remove it? When we remove the power supply to the coil, through this coil, if this power supply is removed, the coil will get demagnetized. As we know, because of this electricity, the magnetism effect is produced, and when we switch off the electricity, this magnetism effect is no more. It gets demagnetized. So the movable armature gets back to its original position because of the spring action as shown in figure. The output circuit operates a high current appliance such as lamp or an electrical motor. So this output circuit here, in example, it is a lamp and it is used to drive this. So this is an example of an relay. Now let us study another switch, which is a solenoid. Now many of you must have heard about solenoid. So let us see what actually a solenoid is and what is a solenoid valve. Let us study that. Okay. Solenoid is an insulated copper coil and is wound around some electrical cardboard. Suppose, right, let us study further. Or a plastic tube such that the length of the coil is greater than its diameter, then it becomes a magnet. So is nothing but a copper coil and is wound around some cylindrical cardboard. Cardboard होता है जिसके अंदर हम उसको wound कर देते हैं, right? Now what is solenoid? Solenoid is an electromagnetic device made up of a coil which produces a magnetic field when electric current passes through it. Now this is an example of a solenoid. In solenoid there is a ferrous core. This is a ferrous core and this is a spring. So here it is shown as energized. So as soon as you energize this, what happens is this ferrous core goes down and it gets energized, producing the magnetic field like this, right? So when the electric current passes through it, then it is energized and attracts the ferrous cores as shown in figure B. So as soon as it gets energized, this ferrous core shown here, it goes down, right? If the supply is removed, the coil is energized and releases the ferrous cores as shown in figure A. Similarly, as we remove the electrical supply, this will go up, hence removing it. Such solenoids are used in relaying energy from one device to another and are used mainly in opening and closing of valves. As shown in figure, we'll show the figure in next slide. So the function of a solenoid valve is to use it as a switch, and application it's in the fluid, mainly in the fluid and in industry also, right? The solenoid valves, when the solenoid coil is energized, the valve opens, allowing water to flow from the reservoirs. As I said, that its application is in the field of fluid, right? The reservoir into the fixed tank, otherwise the valve is closed. Applications are robots, dishwashers, etc. Based is fluid based application, right? Now let us see an example of a solenoid valve. So here is an example of a solenoid valve. It is a pressure adjusting screw. Here there is a spring, and through this pressure adjusting screw a spring is attached. All right. Now here is a plunger. Plunger, you can understand it's like it is moved as a moves as a to and fro motion. A plunger is used in an injection. It is like it's like a piston device. All right. And here is the valve, and here is the inlet. Water flows like this. Now if the valve is closed, no water will flow. It means that it is de-energized. So as soon as you turn on the current, this valve will go up, it get energized, and it opens, or it can happen vice versa. As soon as it opens, the fluid of water, the fluid will start flowing like this, and it will go outside. So this is an example of a solenoid valve, solenoid energized valve. Here is a solenoid energized valve. I hope you got, you understand what is the type of an solenoid valve. Now let us come to the topic of motors. Till now we have studied the switches. Now let us study motors. What are the types of motor? And we will be studying about DC motor. Now a motor is an electrical machine which converts electrical energy into mechanical energy. So this is what is the purpose of motor. Electrical motors are frequently used as final controlling element in position and speed control system. As you know that at the end shaft of the motor, we attach what we want to drive. Basically, it consists of two parts. One is stator and one is rotor. So this is how the motor is classified. It is broadly classified into three categories. One is AC motor, which take alternating current as supply. One is DC motor, which take direct current as supply, and one is special motor. Special motor types are stepper motor and servo motor. And types of AC motors are synchronous, asynchronous, and DC motors are series, shunt, compound. So these are the classification of motor, but in today's lecture we will be focusing on DC motors. And let me also tell you about these special motors, stepper motor and servo motor. These motors are highly used in specific automation program, like automation machines, like robots, because we want, and suppose if you are using a pick and place robot, there you require a high amount of precision. So you use these special types of motor so that you can put, suppose if I take an example of a pick and place robot, so robot will be able to pick some material and put it in a precise location. So when precision is required at high amount, we use special types of motor, which are stepper motor and servo motor. So now let us study the DC motor. So DC motor essentially look like this. Now let us see. Now this is a front view of DC motor. There are multiple diagrams of DC motor in the subsequent slides, so you will get more idea about what is a DC motor. But right now I want to show you what are the parts of DC motor. Now this part, external casing, is known as yoke. There is a terminal box in which all the wire or windings are attached. This is a pole, and these are these are field winding. This is an armature which revolves inside a DC motor, and these are the conductors here. It helps us to move the armature. This is here is our brushes. There are two brushes, one is here and another one is here. And this rotating part here is known as a commutator. Now these parts may seem to be new to you, like what is an commutator, what is armature, but as you study about DC motor and you see the diagram of it, the understanding will become easy. So let us see another diagram of DC motor. So this construction is the simplest of DC motor. Now here in DC motor, it works on the principle like that. There are two poles. One is south pole and one is north pole, and its polarity remains same, right? Now, this is known as brush, which was seen in the earlier diagram. Here is also another brush. This is known as commutator segment, again a commutator segment, and this is brush is attached with a DC power supply. Through here, the current is supplied like this. Now, what happens is, as the current is supplied through this commutator and this armature starts to move. Now, how it starts to move? Let us see with the help of next diagram. So, what happens is, as soon as you apply the current, the electric current passes through the coil in the magnetic field. Electric current passes through this, and as we know with the help of our Lenz's law, that when an electric field is produced in such a way that when electric current passes through this, it energizes and it becomes a magnet. So what happens is, if this is south pole, for some time this will also become south pole, and south pole will repel each other, and this armature will start to move. So when electric current passes through a coil in magnetic field, the magnetic force produces a torque and it starts to move. It produces a torque which turns the DC motor. So it starts to move like this. Now what you want to do is, as soon as it becomes here, it becomes this south pole repel. As this south pole comes here, after one rotation, you will see that it would want to stick here, right? Because now it has the polarity, opposite polarities have reached each other. Now it will try to become stable. It will try to gain equilibrium. So what the engineering marvel we do is, we straight away reverses the polarity. Now as the polarity reverses, this area, this end this poles gets changed. It again become north pole, and north pole again repel each other. It will again move. So this continuous motion we try to achieve, because if we achieve this continuous motion, the shaft attached to this, it will keep on rotating. It will be a self-energized DC motor. So it is also important that you know it is self-energized DC motor. Now, how to calculate the direction of this magnetic field? The direction of this magnetic field is calculated with the help of this Fleming's left hand thumb rule. Now, Fleming's left hand thumb rule is given by this. The current is shown with this middle finger in this direction. If you put your hand like this, the middle finger, the middle finger will show the direction of current, the index finger will show the direction of magnetic field, and thumb will show the direction of force, like how where the force is applied. So this force applied is moved in such a way that this winding starts to rotate. Now, when it produces a magnetic field and produces a torque, the commutator then reverses the current each half revolution to keep the torque turning the coil in the same direction. As I discussed earlier, this commutator reverses the current direction. As the current direction is reversed, the polarity will be reversed, then poles will repel each other and it will keep on rotating. So electric current supplied externally through a commutator, right? So this is how we achieve a continuous motion of this commutator and a constant torque is produced. Now this is working principle of a DC motor. Again, an drawing has been shown. This is the north pole and this is the south pole. This is the battery through which a current is supplied. These are the brushes, and this F is the direction of force, and this is the direction of magnetic field, which is represented by B, and this is a conductor, right? Flux lines, right? Now, we know that whenever a current carrying conductor is placed in a magnetic field, like in our diagram, we have shown that a current carrying conductor is placed in a magnetic field, it experiences a mechanical force. The direction is force given by Fleming left hand rule, as we discussed right now, and its magnitude is given by F is equal to BIL, where B is magnetic flux density, I is current, and L is the length of the conductor. Same magnitude and opposite forces act on the left and right side of the conductor, causes torque, which is given as T is equal to F cross R, or if we write it vectorically, it should be written as T is equal to R cross F, is produced. So torque is produced in the circumference of the conductor. Because of this twisting force, motor starts rotating in anti-clockwise direction because of this force. and the direction of the motor can be controlled by simply changing the supply terminals. As we change the supply terminal, the direction changes and the commutator will keep on rotating. So one important point comes is known as back EMF. Once motor starts rotating, the conductor cuts the magnetic flux lines, causes EMF, and this is given by this, where N, P, phi, Z are given by N is speed of the armature, P is number of poles, phi is represent magnetic flux lines, is number of parallel path, Z is number of conductor. So this induced EMF opposes the change causing it. So according to Lenz's law, we know that induced EMF opposes the change causing it. Here it opposes the supply voltage, hence it's called back EMF. Now how back EMF is described is as, and how it is significance is, it helps to regulate the flow of armature current to meet the load requirement. So that is why DC motor is known as self-regulating machine, and its magnitude is directly proportional to the speed of the motor. So if I talk about, in the other hand, if DC motor is suddenly loaded, the load will cause decrease in the speed. Due to this decrease, back EMF will also decrease. That is why we call this a back EMF makes a DC motor self-regulating. So this is how we can show that back EMF is so important in case of a DC motor. So this is what a DC motor is all about, how back EMF is important and how we can say it is a self-regulating DC motor. So in this lecture, we studied about the switches, what is a relay, what is a solenoid valve and solenoid switch, and we talked about the working and construction of DC motor. That is all for today. In next lecture, we will be talking about the control system and we'll be studying about the PLC. Thank you. Jai Hind.